All right, page 9 in your notes, and as just previously mentioned, you have your final skills check of this module tomorrow, skills check 2 for module 4, and your test over all this material is Friday this week, the day after PSAT. On page 9, I would like for you to copy down the text that's right there next to where it says reflectional or line symmetry, and I would like for you to copy down these shapes in that space that you have between numbers 1 and 2. Make sure you don't fill that space entirely because we are going to do a little bit of writing there. Page 9. All right, so symmetry. There's 2 types of symmetry we're going to talk about. One of them is reflectional or line symmetry. That's what we have right here. When we have line symmetry, that means the figure can be folded across a line, what we call the axis of symmetry, and it can be reflected onto itself. Cuts a figure perfectly in half. It has to line up perfectly with the other side. So I'm going to look at some examples of shapes that have or possibly don't have line symmetry. And we're going to look for how many lines of symmetry they have. First one we have is this smiley face. Do you think my smiley face has any lines of symmetry?
Yes.
Yes. Now, when I cut this smiley face and I fold it, it would have to match up perfectly, not just the outline of the smiley face, but the eyes and the mouth would have to match up perfectly as well. Yes.
Do you need to draw these?
Yes, you do need to draw these. Where could I cut this smiley face and fold it so that it would match up perfectly with the opposite side? Right in between the eyes. We go right here, and I folded it across that line. The eyes will land on top of each other, and the smile will match up perfectly. Is there anywhere else that I could cut this so that the smile and the eyes, along with the edge of the circle, would match up perfect? Well, if I cut it between the mouth and the eyes and I fold it, the mouth would come up to the top. Do we have a mouth up on the top? Okay, so that's what I was saying when I said wherever you do this, like when you fold it, it has to match up identically with the other side. Like if you lay it on top of itself when it's folded, you can't tell a difference between which one is the bottom and which one is the top, or which is the left and which is the right. I like what you're looking for, though. That's exactly what we need to be looking for and checking for. This particular figure right here, we say has one line symmetry. This is the only place where I could cut this figure and make the halves match up exactly. What about the capital letter E? Is there anywhere that I could cut that one? Yes. Yep, like through the little leg of the E. Yeah, we can go horizontally, straight through the little leg of the E. Then I could fold the top down on top of the bottom. It would line up exactly. I wouldn't be able to tell which is the top and which is the bottom when they're on top of each other. Is there anywhere else that I could fold this to make it match up with itself exactly? No. So we would also say that this one has one line of symmetry. And then I have this hourglass type shape. Does the hourglass have line symmetry, do you think?
Yes.
Yes. How many lines could I draw in? Two. Where could I draw them? Yep. I can go horizontally like this, cutting it into a big triangle on top and a big triangle on bottom, where if I fold the top down, it matches up with the bottom perfectly. Or we can cut this vertically, absolutely. That would cut it into 4 little right triangles that if I folded the left on top of the right, those would match up perfect. We would say this has 2 line symmetry. What about the X? Does that one have line symmetry at all?
Yes.
Yes. Where is at least one line that I could draw? Straight up. So we can go vertically. Anywhere else? I can go horizontally. Anywhere else? What'd you say? Down each of the lines. So I can cut it diagonally like this. And if I were to fold it on that line, this upper left part would land on top of the lower right. Or I could make my fold go in the other direction. So this one has 4 line symmetry. All right. Now my circle. Do you think a circle has line symmetry? Yes. Where's somewhere that I could cut this circle and fold it so that it would land exactly on top of itself? I can cut it horizontally. Anything else? I can go down the middle. We can go vertically. Anywhere else? I can go diagonally. Can I do both diagonals? Yep, I can go diagonally from upper right to lower left, or upper left to lower right. Is there anywhere else? Could I cut this diagonally right here? Yeah, it's not the same diagonal, but it still works. What about here? Could I do that? Yes. Is there anywhere, as long as I'm going through the center of it, is there anywhere that I couldn't draw a line of symmetry? No, as long as I'm making sure to go through the center, we have an infinite number of lines of symmetry. Mm-hmm.
Is it because it's a cycle?
Yes, it is. No matter which way I turn, twist, or fold a circle, as long as I'm going through the center, it's going to match up with itself because the circle is identical all the way around. It is equidistant from its center. The edge of the circle is equidistant, same distance from the center. What about that capital letter R that I've got on the end there? Does that one have line symmetry? No. We have no line symmetry here. There is nowhere that I could draw a line through that capital R and fold it in half so that it matches up perfectly with itself. All right. So that's one of the types of symmetry that we're going to be looking at. And as you guys are getting ready to finish up the homework, or when you're taking the skills check tomorrow or on the test on Friday, If you find that you would like some tracing paper, so you can trace the shape on top of it and then you can actually fold the paper, you are more than welcome to do that. You may use the tracing paper for any of the symmetry stuff, line or what we're getting ready to talk about, which is rotational. Keep in mind though, when you're using the tracing paper, there's some human error involved. So if you make a little accidental squiggle with your pencil and then you fold it and you're like, well, it doesn't match up perfectly, like, leave some room for human error. Leave some room for your own mistakes with your pencil. All right. Then we have rotational symmetry. Go ahead and copy this down into your notes for rotational symmetry. You're welcome. I can't, but I can read it. I'm sorry. I wish I could make it bigger. It says the figure can be rotated about its center onto itself. And then underneath in that smaller text, it says the figure looks exactly the same after rotation. You're welcome. The figure can be rotated about its center onto itself, and the figure looks exactly the same after rotation. And then before we write down about order and magnitude, I would like for you to copy these shapes into that little space. We have a Z shape. We have an X shape. There's a rectangle. Currently I am drawing an octagon. An octagon has 8 sides. I'll do my best. Something like that for an octagon. And then we're also going to have a heart. So go ahead and get those 5 shapes into your notes. All right. So with our rotational symmetry, like the definition says, this figure can be rotated about its center onto itself. So if I was doing this with tracing paper, I would take my tracing paper and I would set it down on top of my shape. I'm going to trace over it. And then I'm going to put my pencil right in the middle of that shape so that I can rotate and the paper won't move from that center point. It'll just spin around in a circle there. If the figure lands exactly on top of itself, then we say it has rotational symmetry. The number of times that I can make it land on top of itself until I get all the way back around to where I started, that's what the order is. So this is the number of times a figure maps onto itself as it rotates from 0 degrees to 360 degrees. So when I'm doing this with my tracing paper, I trace the figure on my page, and then I usually put some kind of a mark so that I have a starting location, so that as it matches up with itself, I can tell when I get back to where I started. And we'll look at that as we're doing this with some of these shapes here. I'll show you exactly what I mean. The magnitude, sometimes called the angle of rotation. This is the smallest angle through which a figure can be rotated so that it maps onto itself. And the way we find magnitude is 360 degrees divided by whatever the order is. (360 degrees divided by whatever the order is. Let's look at a couple of examples. All right, so the first example we have here is a capital Z. So again, here's what I would be doing. I would take my tracing paper. I would trace on top of this. I'm going to mark where the top is. And then I'm going to put my pencil down as close to the center as I can. So right about here, something like that. And I'm going to hold my pencil firmly there. And then I'm going to rotate. Sorry, I have to redraw this. Trace on top of it. Mark the top. Put my pencil down at the center. And holding my pencil still, I'm going to rotate this around to see if I can get it to match up exactly on top of itself. And you guys can see I put my mark not quite in the center, but if it had been in the center, do you see how it lands exactly on top of itself? It's just upside down here. And then I continue rotating it back around, stopping periodically to see if it matches up with itself. And again, if I had put my pencil down in the exact center, it would be lining up. Sometimes I'm going to be wrong about exactly where the center is, and so you saw how it was off a little bit, but I can recenter my tracing paper here. How many times could I twist this around, making it match up with itself until I got back to the beginning? 2 times, yes. We did once this way, and then back to the top. So we would say that this has an order of 2, or this also gets called twofold. And then we're going to come in and do magnitude. Does anybody remember from what we wrote down up above how we calculate the magnitude? Yep, so 360 degrees divided by 2, by the order. So 360 divided by 2 to get my magnitude. What is 360 divided by 2? 180, yes. So this Z shape has a magnitude of 180 degrees. All right. Let's try our X shape next. So grabbing my tracing paper, I'm going to trace on top of this figure. I'm going to put my pencil down here. And I'm going to put like a little star shape. I'm starting over here. That's not necessarily the top. That's the top right. I just need to make some kind of a mark so that I know where I'm starting from. And then I'm going to begin twisting this, seeing if I can get it to match up with itself. Looks like my human error came into play here. If my X had been perfect when I drew it, this would be matching up. So that would be 1. Means I didn't do such a good job of drawing my example. There's 2. That should be 3. And then back to where I started would be 4. So we would say this has order 4 or fourfold. Now, just so that it's been said, if this was a homework, a test, or a quiz, I would not have been okay with that much difference as I rotated it. I drew this X as an example. It wasn't one of the ones that was printed for me. But normally I would not tolerate that much difference as I'm rotating it. If this was on a homework or a test, I would say it has order 2 because it only matched up perfectly with itself twice. I'm just not such a great artist. Sorry, guys. All right, so there's my order, which means the magnitude would be what? 90. Magnitude, we do 360 divided by the order, which is 4, and that gives us 90 degrees. All right. What about this rectangle shape? Do you think that has rotational symmetry? Yes. How many times do you think I can rotate it until I get back to where I started? Twice, yes. Let's trace around it. I'm going to mark my top, put my pencil down in the middle as I twist it around. Right here it would match up. So there's 1. And back around to the beginning. So I could go around like this until the top is on the bottom, and then swing it back around here. With my X, we could do that 4 times. So with the rectangle, what's the order? Order is 2-fold, yes. What about the magnitude? 180. To get our magnitude, we do 360 divided by the order, which is 2, and that's how we get 180. Then I have an octagon. Do you think the octagon has rotational symmetry? Yes. How many times do you think I could twist it on my page? 8, yes. Like if I started right here, I could go 1, 2, 3, 4, 5, 6, 7, and then get all the way back here to 8. So we'd have order 8 or 8-fold. And then magnitude would be what? (360 degrees divided by 8? Yes, it's 45 degrees. Very nice. I didn't trust my art skills enough on that one. Yes. Not necessarily, but are they often related to each other? Yes. They're often related to each other. Sometimes we'll have line symmetry and we don't have rotational symmetry. But what you picked up on, and we're actually gonna, since you brought it up, we'll come down here and talk about this before we do that heart. When I have a regular polygon means all the angles are congruent and all the sides are congruent. With n sides, so however many sides it has, n sides would just be number of sides. So when I'm looking at a shape like a square, or like this octagon that I tried to draw, where I tried to make sure all of my sides were the same size. When we have a regular polygon, all the sides are congruent, all the angles are congruent. However many sides I have, that's how many lines of symmetry I will have. So we will have n lines of symmetry, and the order will be n, or n-fold. And so then the magnitude would be 360 degrees divided by n. When I have a regular polygon, whenever I have a shape where all the sides and the angles are congruent, like here with this octagon, however many sides I have, that's how many lines of symmetry I'll have. However many sides I have, that's what the order will be. And then I find the magnitude by doing 360 divided by however many sides I've got. This only works for regular shapes. If it says it's a regular polygon, a regular hexagon, or a regular pentagon, or a regular nonagon. All right, there was one more shape that we didn't talk about with rotational symmetry yet, and that was the heart. Does my heart have rotational symmetry? Can I, as I'm twisting it around on my page, as I'm turning it around the center, will it ever match up with itself until I get back around to the beginning? No. So we say this one has no rotational symmetry. No rotational symmetry for my heart. Because when I trace around this on my tracing paper, let me do this for us here. So I'm tracing around it in red. I put my pencil down in the center, and as I turn it, is there anywhere that I can stop it before I get back around to where I started, where it would land on top of itself perfectly? That's why we would say it has no rotational symmetry. Does that make sense?
Yes.
If you have to go all the way around to make it match up with itself, we do not have rotational symmetry. All right. Let's look at both kinds of symmetry with these 6 examples on the lower half of the page. First shape we're looking at is an equilateral triangle. What does this word equilateral mean? Yes, this means all the sides are congruent. And with an equilateral triangle, because all my sides are congruent, all my angles are congruent too. What did we just call shapes where all the sides and angles are congruent to each other? There was a word up above. Regular. This is a regular triangle. Do regular polygons have line symmetry? Yes. So we do have line symmetry. I'm going to put a yes there. How many lines of symmetry would it have? 3. How many sides does it have? Then it has 3 lines of symmetry. If it is a regular polygon, the lines of symmetry that it has is equal to how many sides it has. Let's go ahead and draw them in. So there's 1 if I go straight down through the center like this, straight through that top vertex. There's 1 if I go through this lower left vertex. And there's 1 if I go through the lower right vertex. So we have 3 line symmetry. Do we have rotational symmetry? Yes. With an order of what? How many times could I twist this and make it map on top of itself? What rotational symmetry means? That's what we just did all these examples of right back here. You have to try it. You have to use tracing paper usually. It's whether or not you can twist it. The more practice you get with twisting it on the page and seeing whether or not it matches up, the easier it gets to recognize whether or not something has rotational symmetry. So what I would do on my page is I would take my tracing paper, I would trace over the figure, I would mark which piece was the top so that I'd know when I got back around to the beginning, and then I would start turning this. So I would go twist, 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 it's not matching up. Right there, it matches up, so there's 1. Notice how my T is down here now. And then I can twist, twist, twist. And I don't have it in the exact center, which is why it's ending up off as I'm twisting it. There's 2. And then to get it back to where we started, it took me 3 times of stopping. Every time it matched up with itself, I had to stop. So when I went here, it matched up. So that would be 1. And then when my T got over to this corner, I had to stop again. So that would be 2. And then we got back to where we started. So that was 3. So we have order 3 or threefold. How would I find the magnitude then? Yes, we're going to do 360 divided by the order of 3. What is 360 divided by 3? 120. So my magnitude is 120 degrees, and we got it by dividing. Part B. What is this shape? It's the recycling symbol, which has the basic shape of a triangle, right? But it's got some extra pieces to it. It's got these little arrowheads in here that have been drawn in. If I were to draw in a line like this, just like I did on the other triangle, if I folded it over that line, would the 2 halves match up exactly perfectly? You couldn't tell which side was which. No. Is there anywhere that I could draw a line like that and fold it so that it would match up exactly? No, those arrowheads are throwing things off. When I reflect it, those arrowheads mess me all up. So do we have line symmetry here? No. No line symmetry. Do you think I have rotational symmetry at all? Yes, we do have rotational symmetry here. Here's where I would pull out my tracing paper. I would trace over these shapes. on my page. And then I would put my pencil down in the center after I mark which side is the top. And I'm going to rotate it. Yep. Did I get it to match up? Okay, so there's one. And then I'm going to rotate it around again. Did I get it to match up again? All right, so there's two. And then I know it's going to match up when I get back around to the top. So what would the order be? 3 or threefold. We had 3 rotations in here, which would mean a magnitude of what? 120. 120 degrees. Gotten there by doing 360 degrees divided by our magnitude of, divided by our order of 3. Arian, did that make a little bit more sense with the rotational there as you see it move? And I have a ton of tracing paper. This entire container up here is filled with tracing paper. You are welcome to take absolutely as much as you want to do your homework tonight. This will be accessible when you do your skills check tomorrow, and you will have access to it on the test. So if you want tracing paper, you can absolutely have that. All right, what about this double-ended arrow? Do you think we have line symmetry with the double-ended arrow? Yes. How many lines of symmetry could we draw in here? 1, which way? I heard vertically. If I fold the left over on top of the right, I wouldn't be able to tell which is which. Are there any other lines of symmetry? Can we do it horizontally? Do you guys think we could fold it right there? Yes. So how many lines of symmetry? 2 line symmetry. Do you think we have any rotational symmetry? Do you think we have rotational symmetry? Oh, I'm seeing some yeses. Let's go ahead and write down yes, and then let's look at what it is. So tracing around the outside of my shape. All right, there's my shape, and I'm going to mark this as the right side. I just need some kind of a marker so that I know where I'm starting from. If I take my tracing paper now and I begin to twist it, rotate it around the center, can I get it to match up with itself? Yes, there's 1, 2 total, because I can't stop anywhere else until I get back to where I started. So we can take it from here around and back to the beginning. So 2 or twofold on my order. Which would give me a magnitude of what? 180 degrees. Which again is found by doing 360 divided by my order, which was 2. All right. We've got 3 more examples. We need to go kind of quickly through them, but then that'll finish us up. This plus sign, do we have line symmetry here? Yes. How many lines of symmetry could we draw in? Tell me where to draw. Ooh, I saw a 4. Tell me where to draw them. All right, we can go horizontally, vertically, and the 2 diagonals, absolutely. So we have 4 line symmetry here. Do we have rotational symmetry? Yes. With an order of what? What do you think our order would be here? 4. 4 or fourfold. And that would give me a magnitude of 90 degrees. 360 divided by 4. Arian, when I see I have line symmetry, I will usually think, hey, I bet I have about that as the order. It's not always perfect, but it gives me something to look for in a starting place. On E, do we have line symmetry here? Yeah. Yes. How many lines of symmetry? Close. 6. Here's 1, 2, 3. If I go through all the little spikies here, and I can get another 3 by going through the petals. 2, 3 for a total of 6. Do you think we have rotational symmetry? Yes. Does anybody want to take a guess at the order? 6 is absolutely correct. So 6-fold. If I had the time, I would show you this with that virtual tracing paper that I have. So that would give me a magnitude of what? 60 degrees. 360 divided by my order. All right, last one. I have a diamond shape. Do you think we have line symmetry here? Yes. How many lines? Not infinite. I like what you're thinking now. 2. We have 2 line symmetry here. I can go diagonally this way and make it match up, or this way. I cannot go vertically or horizontally. If I tried to go horizontally, this dot right here would end up here, which is not exactly on top of my shape. Do you think we have rotational symmetry? Yes. What do you think the order would be? Order would be 2 or 2-fold. It would mean taking this corner over to here, and this corner over to here. What would my magnitude be then? 180. 180 degrees, or 360 divided by 2. Your homework is due tomorrow. Hopefully all you have left to finish up is this symmetry stuff. And you are welcome to come up and help yourself to as much tracing paper as you would like to help you complete that assignment tonight.